Okay, our next piece is, these are several of the techniques, several of the tools you have in your toolbox to accomplish this notion for an identity. Now, let's suppose, just generically, we have left-hand side, I'm going to say LHS. We have the left-hand side is equal to the right-hand side, and we're asked to verify this identity. So the left-hand side might be some expression involving sines and tangents, or right-hand side might involve secants and cosines and sines. So these are some expression involving the trig functions and some expression involving the trig function. It might be very simple. The right-hand side might be 1. The left-hand side might be 1 plus sine squared. It could be something very simple, but we have left-hand side equal to right-hand side. Our task is to verify, or to essentially prove, that this is a true statement. All right? So the next piece is this. What we want to do is be able to say this. This is the procedure. We will start with one side or the other. Start with one side or the other. Typically, you want to start with the more complicated side. Let's assume that in our example, the left-hand side is more complicated than the right-hand side. So I'm starting with the left-hand side. Let's assume it was more complicated. Now, the structure, the form of the argument goes this way. I'm going to take the left-hand side and change it in some way so it becomes A. And then I'm going to change A, statement A, whatever it involves, manipulate it and change it so it becomes statement B. And then take statement B and change or manipulate it until it becomes C. And then C, change and manipulate it until it becomes statement D. And then maybe statement D, you change it or manipulate it in some way, and it becomes the right-hand side. So the goal is to start with one side or the other. You do not need to start with the left-hand side. You may, if you wish, start with the right-hand side. Either is allowed, but typically it's usually easier if you start with the more complicated side. So let's assume left-hand side is more complicated. Left-hand side is equal to A, and then you change it to equal B. And so you've changed each of these in some way. Maybe statement A involved tangent of X, among some other things, and you changed it into sine of X over cosine of X, and some other things. So you've changed A into B, and they're equal, but now it looks a little bit different. And then you change this into something else. So the logic says this. This is equal to A, which is equal to B, which is equal to C, which is equal to D, which is equal to the right-hand side. Therefore, the left-hand side must equal the right-hand side. That's the logical flow. So, some tools you may use to do this are, well, we've done it here. Notice, if you have tangent, it is one thing you may do, is one thing that is convenient. In fact, this is very often done. Every function that appears, you change everything to sine and cosine and work with that. Watch for identities. If you have sine over cosine, maybe you might want to change it into tangent. Or if you have sine squared of x plus cosine squared of x and some other things, you may replace this with 1 because that's one of the identities we know already. So watch for the identities that you know already. Keep an eye on what you're aiming. You want to manipulate this, but you don't want this thing to just grow and grow and grow and go out of control. You want to funnel this down so that it equals the target you're trying to hit in the first place. So keep an eye on the target. Make sure you keep in mind what it is you're looking for. Now, another thing is this. It's called the conjugate multiplier. Here's what that means. Very often expressions look like this. You might have it in this expression. You might have sine of x plus 1, or sine of x minus 1, or it might be 1 plus sine of x. All right? Well, the conjugate of 1 plus sine of x is 1 minus sine of x. So multiplying by a conjugate is a technique that is very often employed in this procedure. we will do several examples where that's going to come into play, but I want you to be aware of it so that that's something you're bearing in mind. Multiplying by the conjugate is a technique that we will encounter here in just a little bit as we do a few more of these examples. All right? So, let's look at a specific case now. All right, so a specific case. We're going to prove this. Our statement is this. Secant of x, here, start over here. Secant of x times sine of x plus cosine of x is equal to tangent of x plus 1. All right? So this is what we're asked to prove. Prove, or very often the word is verify. In this context, the word verify means to prove. Prove this is a true statement. All right? So, start with the more complicated side. I think it's probably fair to say the left-hand side is more complicated. But don't start from here. Do not start from here. You physically write down the side that you believe is the more complicated one. So you state your intentions with my problem. So there's the left-hand side. So I've started with what I believe is the more complicated side. Now you need to do something to this so that you can change it and somehow manipulate it so that it equals what we're trying to find is tangent. All right? Well, what do we have on offer here? Look, we can change all the functions to sine and cosine. That's really you'll be using that quite frequently. Is it clear? Secant. What's secant? Do we remember the reciprocal identity? Secant is 1 over cosine times sine of x plus cosine of x. All right? Then what? What can we do here? Well, another I don't have written here is do algebra. And what does that mean? If you have fractions to add them. If you have expressions to factor them. If you have distributive property, distribute it. So watch for the algebra, do the algebra. And we actually have a distributive property here. We have 1 over cosine times this quantity, sine x plus cosine x. You can distribute. So if you distribute this in, remember it's top times top, bottom times bottom. Remember whenever you have fractions, top times top, bottom times bottom. So distribute, this becomes sine of x over cosine of x, top times top, bottom times bottom, plus top times top, bottom times bottom. Keep an eye on the target. Are we getting any closer to tangent? I think we can kind of see what's going on here. We're getting there, aren't we? Right? Watch for identities. What is sine over cosine? Don't we know sine over cosine? So very often we change it into sine and cosine, but now once we've done some work, we want to reverse the process. We're trying to get tangent of x plus 1, and I think we can see it smacking us right in the face here. Sine over cosine is tangent of x, and cosine over itself is 1. That is the right-hand side. We don't need a box around that. And so the proof is done. If any of you have Professor Bratz always would put a cup of coffee here. There was a famous mathematician who said mathematicians are machines that change coffee into proofs. And so we drink coffee and we make proofs. And so anytime you do a proof, you put a little cup of coffee. We have proven that we start with the left-hand side is equal to this, which is equal to this, which is equal to this. Therefore, this is equal to that. A is equal to B, B is equal to C, C is equal to D. Therefore, A is equal to D. So this is a verification of this identity, and that's been proven.